Welcome to part 4 of week 1 of our learning guide for college algebra. I hope you're finding the learning guides to be very helpful as you're kind of trying to take in all of the information for week 1 of the college algebra course. I know it is a lot. And so I designed the learning guides as a way to break it apart piece by piece, but also to give you some examples that you can rely on. So just a couple of reminders. One, be sure to subscribe and hit the bell so that you make sure that you get a notification every time a new video is posted that will help you with more content throughout this course. Also, this video will focus only on these 4 examples. So I'll put the links to the other videos for week 1 in the comments section is so that you can follow through with those if you need to do that. Also, if you don't have this learning guide in our PDF format, click on the link below in the description so you can download it and follow along as we're working through the problems. So this video is going to work through topics of greatest common factor and factoring. So we're going to really be looking at those topics. I've given you a graphic here to rely on later, but I want to talk through it through the examples so that you have resources to come back to. So if we look at problem 1, it says to factor by the greatest common factor. So just a reminder, greatest common factor is the biggest term that will divide into each of these terms. That word biggest gets to be a little bit confusing, so you have to be careful. You first want to look at the numbers involved. And is there a number, the biggest number you can think of, that will divide into each of these numbers? And when I say numbers, I'm looking at the coefficients in front. So notice a coefficient of 2, -2, and a coefficient of 3. Now, the biggest number that would divide into 1, -2, and 3, of course, would be 1. So I don't have a number, a coefficient for my greatest common factor. However, now look at the variables. They have an x to the third, they have an x to the second, and they have an x. So my greatest common factor would be the variable with the highest exponent possible that can divide into each of these. And in this case, that is just an x. So notice I put the greatest common factor in front of a parentheses, and then I have 3 blanks. Now, those blanks come from the 3 terms that you see here. And we're going to fill those blanks with what we get when we take the term and we divide by the greatest common factor. So I took the term and I divided by the greatest common factor. That is what I will put in this blank, which x to the third divided by x would be x to the second. Let's do it for this second term. I've got the term is 2x to the second, and I'm dividing by x. And that is what I put in this blank. That would be 2x. And then the last one would be 3x and divide by the greatest common factor. And that would go in this blank, and that is 3. And that is how you divide, that is how you factor by greatest common factor. Okay, let's do the same thing for number 2, but then we're going to have to take it a step further. Just beware. Okay, so let's do number first. The number that will divide into 5, -30, and 45 would be 5. So we'll put that in front as part of our greatest common factor. Now look at the variables. They each have an x. They each have a y. That's the biggest number that they each have. So I'm going to put an x and a y here. Okay, now let's open our parentheses and put our 3 blanks there. And now we're going to take each term and divide by the greatest common factor. So I take 5x to the second y and I divide by 5x y. And that gives me, let's see, the 5's would go away, the y's would go away. I'm left with just an x. Let's do it again for the second term. I've got 30x y to the second and divide by 5xy. And we divide, 30 divided by 5 would be 6. X divided by X goes away. Y to the second divided by Y gives me just a Y. And then the last one, 45xy divided by 5xy. So 45 divided by 5 gives me 9, and then the x and the y's go away, and I'm done. That's it. I factored by the greatest common factor. Now, friends, you can check these. And the way you check them is to distribute your greatest common factor back to each term. When you do that, you should get the original problem. So it's a good way to check your factoring to make sure that you are getting the same answer or same answer, the original problem when you distribute back. So factoring is kind of like the opposite of the distributive property. Let's look at grouping now. Now, grouping is going to do factoring by greatest common factor, but it's only going to do it in pieces. So we're going to do factoring with x cubed plus 3x squared. We're going to do the greatest common factor with that. And then we're going to do a greatest common factor with the last two, the negative 25x minus 75. Okay, so greatest common factor here, the numbers don't really have any that'll go into 1 and 3 other than 1. And then they both have at least an x to the second. Okay, so I'm going to divide x to the third by x to the second, and that will give me x. And then I'm going to take 3x to the second, and I'm going to divide by x to the second, and that will give me a 3. All right, now look at your next two. It looks like they both have, and we'll divide by negative 25. I'm saying negative 25 and not just 25 because the first term is negative. So that's a lot of times an indication. So I'm going to pull out a negative 25. I changed it to a plus because when I change that negative, pull out that negative 25, it's going to give me the opposite sign. So now I'm doing negative 25x divided by negative 25. And that leaves me with just an x. And then negative 75 divided by negative 25 gives me a 3. So do you see how what was left in the parentheses actually came out to be the same? Okay, good. I'm glad you're seeing that because we'll watch the transformation. I've got x plus 3. That was the parentheses that was the same. Okay. And I've got x squared minus 25. I want you to see where those came from. All right, I'm going to draw some dots. There. You see where I got the x squared from? And the negative 25. You see where I got that from? That's how I came up with that answer. Okay. Now that is factoring by grouping. I'm going to show you one more method, and then I'm going to come back to this one because it's not quite finished, but I need to show you the next method. And I'm going to show it to you in problem number 4. And it's saying to factor completely. I want you to see this x to the 4th and this 81. They're both perfect squares. Okay. And I want you to see that there's a minus between them. And this is just a rule to learn. Okay. So we call this a difference of two squares. A difference of two squares. Okay. When we have two perfect squares being subtracted, then we can factor into two parentheses, one with a plus and one with a minus. What goes in the blank is actually the square root. So what times itself would give us x to the 4th? Well, that has to be x squared and x squared. What times itself would give us 81? That has to be 9 and 9. See how it's the parentheses are exactly the same, but one has a plus, one has a minus? Okay, now I want you to focus in on this second parentheses then, because these are perfect squares as well. Okay, so let me show you what we'll do. We'll leave the x squared plus 9 because it's taken care of because it doesn't have a minus. Okay, so it's not a difference of two squares because it doesn't have a minus. We're going to take this parentheses and we're going to split it into two parentheses, one with a plus, one with a minus. And what goes in those blanks are the square roots. So what times itself gives us x squared? That would be x and x. What times itself gives us 9? That would be 3 and 3. So we get our final answer. I like colors, you can tell, but this would be my final answer. This would be factored completely as it says. Okay. Now take a quick look back at number 3, and you're going to see why I told you we had to come back to it because looky here. Okay. So let's do two parentheses, one with a plus, one with a minus. Okay. What times itself would give us x squared? That would be x and x. What times itself would give us 25? That would be 5 and 5. That is why our final answer would be x plus 3 times x plus 5 times x minus 5 for problem 3. So I hope that helps you. This is part 4 of week 1 of the College Algebra Learning Guide. I'll put the link to the other videos for week 1 as well, but don't forget to subscribe and hit the bell so that you get a notification every time I upload another video that can help you with the content in our course. As always, if you have questions or comments or something you'd like to see another video of, let me know in the comments below. I'd be glad to help in any way that I can. Bye for now.